Hello friends, how are you? I hope you would be fine. Today my topic is about temporal difference learning for estimating V. If one had to identify one idea as a central or fundamental to reinforce enforcement learning, it would be undoubtedly to be temporal difference TD learning. To TD learning is a combination of MC ideas and dynamic programming ideas. Sutton and Bartow 2017 TD learning learns a value function V of S directly from the experience with TD error with bootstrapping in a model-free, online and fully incremental way. The subsequent control methods such as SARSA and Q learning are directly inspired by TD learning. The goal of TD learning is the same as MC to estimate v pi of s given episode generated under policy pi, but with a different approach. Define the state value function when MDP value model is available, such that the policy pi AFS, AS, and dynamics PS bar or SA are given. We can use Bellman equation or dynamic programming discussed in the previous chapter to evaluate the state value function as shown in figure 2a. Okay, if the MDP model is not available, we can evaluate the state value function through the information on the received return during the experimental interaction with the environment as shown in figure 2b. For instance, in every visit MC, we evaluate the state value function by the averaging the returns over every visits of the state during all episodes, and this can be implemented in an incremental style. uh, where GT is a sample of return following state is the total number of visits of state as till time, like MCTT learning similarity updates the value based on episode in TD. We estimate the return of state as time step at t at as the immediate reward plus discounted old value of the next state st plus 1 as shown in figure 2c, so that we can update the estimate without waiting for entire episode. We define TD target and TD error respectively. The TD target is a new estimate of the value function based on an immediate reward and the old value of the subsequent state. The resulting TD error will be used to adjust the value of the current state. Alpha is a learning rate. A closer inspection of the update equation reveals that the only value change is the one associated with ST, such that the state just visited. Further, the value of ST is moved toward the TT target since the target depend on the estimated value functions. The algorithm uses bootstrapping. The term temporal difference in the name of the algorithm comes from the TT error, which is defined in as the difference between the values of the states corresponding to successive set time steps. In general, the TT target can be evaluated based on the multiple step return through the scenario. Here is one step return called TT. TD learning algorithm. Input the policy pi to be evaluated learning rate alpha. Output the value function v pi. Initialize v pi of s is equal to 0 for all s for each episode do. For each episode T of episode state ST is not terminal, do take action AT by the following policy. Now observe the sample tuple ST AT RT plus 1 ST plus 1 and. Okay, this is the code. In this example, Mars rover is R100000 plus 10 for any actions for S1 to S7 respectively. Pi of S is equal to A1, Y is equal to 1. Any action from S1 and S7 terminates episode trajectory S3 A10 S2 A10 S2 A10 S1 A1 1 terminal. First visit MCVS 1 1 1 and 4 times 0. Every visit MCVFS triple one and 4 times 0. TD with a alpha is equal to 1, VFS 1, and 1, 2, 3, 4, 5, and 6 zeros. The comparison between MC and TD in terms of advantages and disadvantages is summarized as the following table: sequence completeness, Monte Carlo method, and TD method. Must wait until the end of the episodes can also learn from the complete sequences. Okay, so this is it. Time to go. Goodbye. Meet you in the next video.